Alright, recording, and let's see. Socket's good. I think the final we should just play the stick game against Nick, and if we win, automatic pass for the class. Hey, there we go. That's an idea. I could do that, or we could challenge you to dots, you know, if you want. All right, so first things first. On the midterm, there was a what command would you type to compile a class written in a file named sprinklefluid.java, and some people in class asked what sprinkle fluid was, and I told you I might be able to get an answer to that, and I might even get a picture of it. So yes, I got a picture of sprinkle fluid, so this is apparently what sprinkle fluid looks like. So there you go. That's what the class was that that you were compiling. Yeah, that looks really cool, right? All right, so now we know. And yeah, that's Mara's creation. So it is priceless. Sprinkle fluid is like unobtainium. Oh, I could try to auction it off. Yeah, this is going on my wall. All right, cool. Yay. All right, so let's see. How do we capture input that's put into text boxes? So let's play around with that. So give me a sec. Let's fire up Eclipse. I will pass on your compliments to Mara, by the way. Appreciate it. Alright, I don't know what the heck we got here. Let's just play with one of these things and see if there's some code in here we can use. Oh, yeah, that thing. Okay, so let's play with this. So go in the design panel and let's make a text box. So if I put in a text field here, so text fields come with a method called getText, and that's your easiest way to read what's been typed in there. So name of the JText field dot getText. Back, there we go. Right, and that'll return a string, which will be the contents of the text field. So let's put a button in here. Let me name this. Let me just call this name 1. So like this is the first player's name, for example. And let's pop a button in here to take an action. And let's write some code around that. So we'll say Eclipse Code Recommender is experiencing installation problems. I don't want Eclipse Code Recommenders anyway. But I do want to be able to type. right, so I'm just cobbling some code together here so that when you click the button, it says name equals, and then it calls the getText method of the name1 object, where name1 is a text field, and it's just going to print that out to standard out. So if I put in a name, la la la, and I say click the button, right, it can grab that name out of the text field. So that's an easy way to grab a hold of it. For PA4, are we required to have the text boxes unresponsive until the start button is clicked? So the text boxes you're probably using to let the users type in their names, I'm guessing. And those should be responsive until you start playing the game. So the start button I was envisioning is like once the people have entered their names and maybe decided who's going first, if you give them that choice, right, then start begins the game. But if you have a master start button that doesn't let anything happen until you click it, then yeah, you could disable the text boxes. But usually, you know, when you run the game, you can type into the text fields and so on. Hit the start button, and then if you want, once you hit the start button, you can actually disable those text boxes, make them not editable if you want. I don't think I require that, but you know, it's a nice thing so you can't change your name halfway through, because then your initials get confusing and so on. But yeah, start is mainly to say, okay, now I'm going to pay attention to mouse clicks, and until that start button is hit, right, you don't want people to be able to start claiming lines and so on. So just make it look, you know, kind of what would seem like a reasonable game. All right, other questions? Does not have to be exactly 50 by 50 pixels. When I said make the box 50 by 50, my main concern was that, you know, somebody with a really big monitor might decide, you know, to make the boxes really huge, and I'm gonna have to like scroll around to play the game and stuff like that. So, you know, if they're 48 by 48 or 52 by 52, that's okay. If they include or don't include the width of the dots, that's okay. But I want it to fit, you know, in a, you know, no bigger than a 500 or 600 by 500 or 600 rectangle. Let's see. I had a great idea. Combine both sticks and dots together. A typical turn would go like this. Player one picks a line. Then they play a game of sticks to see who gets that line. Oh, cool. Hey, that's pretty fun. Are we allowed to make static methods, right? You should not need any static methods other than public static void main. I'm not forbidding that, right? But you shouldn't need them. But you do want to break things into classes. So here's your dots class, which among other things includes public static void main. So that's your main program, which makes the J-frame, right? And dots, you know, extends your J-frame. So you definitely want your main class, which is dots, but you also probably want a board class, which mostly contains an array of boxes. And you also want some kind of myPanel class, which is where the game is going to be drawn out. So that's an extension of a JPanel. So you probably want at least 4 classes in here. And if you start needing to do statics to make the compiler happy, it's probably because you're trying to do things in your main program. And the main program shouldn't really get changed a whole lot. It should make a J-frame and just be done with it. And you probably don't need to change anything inside main. Now your J-frame, if you're using Window Builder and you drop a JPanel in there, right, that will call the JPanel constructor, and inside here you can go ahead and you can create your game board and so on and so forth. And so when you construct a box bracket bracket, yes, they're all null. So the way we make this array would be something like this. Right? This is not constructing boxes. There's no parentheses here that you would pass to a constructor. This is creating an array. So board now has 64 things in it. And you can say board, bracket row, bracket column, and that thing is a box, but it's not a constructed box. It's null. So before you can use this, you need to do this thing equals a new box. So after you declare this array, pretty quickly you want to make a pair of nested loops, go from 0 through 7, and construct each of the elements of that array, set it equal to a new box. Oh, okay. So yeah, if you do that in the box class, yeah, then I see where you're getting into statics. Yeah, so maybe try doing this in wherever you construct this array. Just do it right after that. And a good place to declare this and to construct, the array and the elements of the array is inside the constructor for my panel, because that's going to get called by the JFrame construction. And this is where all of your mouse events are going to get registered, and this is where all of your painting is going to be done from. So this is a nice place to have, the main object that you use to get to everything, which is your array of boxes. And remember, there's some separation here. When you make a click, you're really going to update something like, board, bracket row, bracket column, dot top. Right, you're going to use this one object, which is your array of boxes. You're going to go into the right row and column based on the XY position where you clicked. And you're going to figure out which edge you're looking at. You're going to look at the Boolean value for that, and if it's already true, that's an error condition. If it's false, you're going to set it to true. You're going to check to see if a box got completed. If it did, you're going to update the score. You're going to, use your flags in a way to say it's still that player's turn, and so on. So your click really just sort of reads and updates this board object. And then the paint method basically, loop over all of those boxes and draw lines. And also draw your dots before you draw lines. I'm having trouble figuring out how to put more than one line on the frame. So more than one line, like a line of a box, like an edge of a box. Yeah. So is it a question of how to set multiple Booleans to be true, or how to make those multiple Booleans translate into multiple lines? So that's the first thing to try to figure out. The click, right, does not call draw line. It doesn't call it doesn't, cause a line to appear directly. The click really updates this array of Booleans, and you've got 8 rows, 8 columns, 4 Booleans each, so 512 Booleans in this array, and you're going to update, typically 2 of them in response to a click. But then your paint loops over all 512 Booleans, right, in all 64 cells, and draws lines wherever it finds that a Boolean is true. So if you're only getting one line, there's 2 possibilities. One, you're only updating, one thing in this board, or maybe you're undoing previous updates, or maybe your paint method is only drawing based on the last click instead of looping over the entire array. So when I press a new location, it redraws the line and the previous line disappears. Yeah, so double check the paint. Make sure in the very beginning of paint you call super.paint. But I don't think that's the problem in this case. So you're going to redraw all the dots and whatever lines need to be drawn every time that you go through your paint method. And that's part of the kind of ugly truth about these kinds of programs, right? Things are constantly being redrawn. Now a good windowing system won't actually, you know, go through all of the work of doing that. It will know what's already drawn and it will draw the new stuff and so on. But yeah, your paint method basically says, you know, start with an empty canvas, which is what super.paint will do, and now draw everything that needs to be seen. So all the dots, all the lines. And the J-frames paint is drawing, you know, all of the buttons and the text fields and the text inside the text fields and so on. And the J-frames paint method is also calling the MyPanel paint method, and that's where your code kicks in. So it's a pretty cool hierarchy of things calling other things. All right, cool. All right, so networking. Let's play with some server sockets. So remember our setup. We're going to have a server. It's got an IP address, and we're going to have some sort of port with a unique port number, unique on that machine, and then we can have clients make connections to that and then send information back and forth. So we're going to do this in Java, and I'll stick with Eclipse because it makes things easy to import, and I probably won't remember all of the imports and stuff. So let's make a new project. And let's call this Wednesday server. And we'll just, let's see. I'll stay away from GUIs for now because we don't need to do this with GUIs. So I'll just make a plain old class and I'll call it server, and I'll let it make a public static void main for me. So here's some code. So the IP will be populated automatically, but you're going to need to specify what port you want to use because that's really your choice. So let's make a socket, one of these endpoints of communication to which a client can connect. So let's look at some documentation. So let's do a server socket. So we can construct a server socket and we can specify a port number. It's an integer. If you create this, then you've got a socket, but it doesn't have a port number associated with it. Nobody can connect to it yet. So we'll usually use this method where we put in a port number. You can also you have the option to set a different IP if you have multiple network interfaces. That's a good question. I don't think that's well formed though. So if you have multiple network interfaces, I think anybody who connects to your machine through any of those interfaces will get to this socket just through the port number. I don't think it's bound to an address. Yeah, so if I have a wire going in, I also have Wi-Fi. I still only have one set of port numbers, one set of sockets, I believe. So one thing we can do, since we're usually, we're creating a server, and we imagine multiple clients trying to connect to us, it may be that while we are dealing with one client, another client might try to connect at the same time. And you can specify, how many multiple connections am I willing to allow before I make people wait, right? Now, if we make that unlimited, we're potentially subject to, denial of service attacks, because you can just make a billion connection requests to a server and overrun the resources. So we can specify the size of a backlog, and I think there's a nominal size set up normally. So let's look at the default constructor. If you specify a port number of 0, it will pick a port number for you. But we're going to pick a port ourselves. And there's some exceptions that it can occur, right? Security exceptions if you try to use a port number that's below 1024 and you're not root. Or if you run out of resources, you can get an IO exception and so on and so forth. But we're basically going to create a server socket with a port as an argument. And then once we have a server socket, we can use any of these methods. And the main method we're going to be interested in is accept. Okay, accept will say wait for a connection to be made, and when somebody makes a connection request, go ahead and accept that connection, establish the two-way link, and return a socket. And a socket is this general thing that's connected to a port that we can use to send and receive information. So let's start off as simple as possible. Let's create a server socket. So let's create a socket on port 1234. So we need to import server socket from java.net, and then this has to go in a try-catch block because it can throw an exception. So I'll just let Eclipse write that code for me. Oh, does it let you specify an IP address? Ah, sure enough, cool. All right, cool, excellent. So yeah, you can bind it to an IP address. Cool, thank you. All right, so let's just go ahead and let's just say socket created. And if I run this, right, it's gonna create the socket. It's gonna say socket created, and then the program exits, right? Because I'm not doing anything. So it just does its thing. But let's do something really goofy here. I'm gonna regret this. Let's just throw an infinite loop in here. All right. So now it's running and it's hanging out. Okay, so good command to know is netstat. So if you say netstat, that gives you information about the status of networky things on your system. And there's tons of information coming out here. So let's just look at the ones that say TCP in the beginning. That's the protocol that we're using. And there's, yeah, right? So enic.para.com, that's my mail server, right? So there's a connection on port 25, that's SMTP, Simple Mail Transfer Protocol. Here's another connection to enic.para.com. And if we look through this, there should be a port 1234. So let's do some. All right, so we don't have anything out there yet. All right, so that's all our TCP connections. These are IPv6 addresses. All right, so let's make this do something more interesting. Yeah. All right. So the next method we want to play with is this accept business. So remember, accept on a server socket will wait for a connection request and then return a socket. So let's do this. We'll make a socket called sock. So let's wait for a connection request. All right, so we'll import our socket class. And then this is going to have to go in a try-catch block. Finally saw what the comment was talking about. And we'll be accepting. Yeah, when my laptop died last year, I needed a laptop right away, so I actually just went to Best Buy and bought something that looked decent, and it was an Acer Nitro. And it's been a really nice laptop, and it got me hooked on high performance solid state drives. All right, so this is so-called junk code. Is it Typo Wednesday? I think it's Typo Wednesday. All right, so what are we doing here? We're making a server socket on port 1234. We're going to call the accept method, and when accept returns, it will give us a socket, which we're calling sock, and we'll print out a message saying we received a connection. All right, so let's go ahead and run this. And so it's just kind of hanging out there now, but let's look at our netstat again. And now if we look at this, we should see a connection on port 1234 somewhere. I'm messing something up. Strangeness. All right. Well, we'll proceed. All right. So next tool you want to know about is telnet. Oh, actually, let me do this. All right. It's a TCP6. So if you do netstat-n, it will use numeric names instead of translating them into something else. And if you do a -A, it will show you active connections. So when I do a netstat-a-n, I see my TCP6 connection. It's not bound to an address yet, but it's listening on port 1234. And the state is listen. So established means there's a two-way connection in place. Close, wait, and last act, these are when a connection is shutting down. And listen is when it's basically a server that's waiting for a connection to be made. So telnet is a useful tool. If you just say telnet, some machine, it will try to talk to port 23 on whatever that address is. And Google hopefully does not have a telnet server running, so they think I'm trying to log into their machine right now. And most of these things you can use these human readable names, and they get translated to IP addresses. So this is the information that's actually sent around in network packets and stuff. But we usually talk about Microsoft.com or enic.pair.com or Google.com. There's a translation that takes place. Probably the weakest link in the whole internet. When things melt down one day, it's going to be because somebody subverted this translation system again. So 127.0.0.1, that's your local machine. It's also called localhost. And so I can say telnet 127.0.0.1. I don't have a telnet server running. I could also just go to localhost, and it also tries to go to 127.0.0.1. So let's go instead to our local host, and let's go to port 1234 and watch what happens down here when I make this telnet request. It says connection received. There's no place like 127. There we go. All right. So my Java code just came back from this call to accept, and it printed out, we received a connection request. And the port, the request came from 127.0.0.1. It was the local machine, and it came in from port 32.896. And if I run this again and I repeat my connection request, this came in from port 32.900, different port number. So on telnets, on the client side, right, the telnet program creates a socket with no particular port number, right? So in this case, port 32.900, and then tries to connect that to the server, which on this side was port 1234. So let's see how much trouble I can get myself into. So let me run this again. And let me see what I got here. Nope, that's not what I wanted. Let's try Terminus. All right, so let's make a connection from my phone to the Unix machine. So let's bring this over here, and I will add a new host. I actually don't know my IP address. 101. So I'll connect to 192.168.0.101. This is, laptop. And let's go to telnet protocol. Nope. And let's go to port 1234. And I think that's all we need. And so let's go ahead and connect to my laptop. And there you go, connection received. And it came from address 192.168.0214. That's my phone's IP address on my network. The local port was, 1234 on the laptop side. Phone socket number was, 48976. And, this is just a client program, so Terminus is a nice program, but, it lets you just kind of make TCP/IP connections to whatever machine you like. So now if one of you tries to connect to my machine, you can't do it because my machine 192.168.0.101, that's not my address on the internet. Right? That's my local network's address. You need to talk to my router with its address, and even if you connect to that, your attempts to connect to my laptop will fail because the router is not sending packets from the outside world to my laptop. Now you can set up port forwarding and say, hey, if somebody from the outside world wants to get to port 1234, send them to this machine on the local network. And so you set up port forwarding, and now if you knew the IP address of my router on the network, you could make a telnet connection to that, port 1234, and it would come through to my Java program. Yeah, exactly. Yep, that's pretty much what it is. Yeah, that's a Pixel phone. I had an Essential that I absolutely loved that phone, but they stopped making it and they stopped supporting it like a year plus ago or something, and so it was way behind on security packages and stuff, so I got an older Pixel. And Subway Surfers, yeah. All right, so this is how networking works, right? And it's did they it's not a lot of code, right? Now, like I said, to do this in C takes a lot more code, but when we create a server socket, we're building in all this machinery. We've got access to all these things, including this accept method, which lets us go ahead and get a connection. So let's take this further. Let's actually play with the socket because as soon as the connection is received, my program is exiting. So let me go back on my other workspace here. So when we run this, as soon as we make the connection, it tells me connection received, but then the program exits because we're not setting it up to do anything else. Ooh, 4XL, yeah. So let's do I/O on these sockets. So let's have this program running in Java just read from the socket and print to our display whatever it reads. So we need to use another method. This comes from the socket class. And we're going to use the method getInputStream. And an input stream is something that's suitable to use with a scanner. So we're going to set this up as follows. So we'll make a scanner sc equals new scanner. Alright, so we'll import the scanner class. And then all of this is going to have to get thrown, get put inside a try catch. But I'm just going to do this manually. Because once I put the get input stream in a try catch, it's going to want the scanner construction to go inside a try catch. All right, so we'll construct a scanner, and then let's read from it. So we'll say received a message, and we'll just do sc.nextLine. And then we'll close our scanner while we're done. All right, so we've added just a little bit of code here. After we got our socket, by accepting a connection, we're going to construct a scanner. So we're going to use the getInputStream method of the socket, use that as an argument to the scanner, and then we'll do our usual scanner loop, which is just while there's another line, let's print out that line. So if we go ahead and we run this, and now we make our telnet connection, we've established a connection, our program is still running, and I can say this is a test, and our Java code gets that message. And then when I exit from telnet, the has next line fails. We kick out of the loop, we close the scanner, and we exit. So we can throw a message in here. So let's go ahead and run that. And we can say telnet, hello Earth. So if we look at our active connections here, you'll see here there's a connection from localhost 1234 to 32.968. That's this connection going on right here. It's established, right? That's the two-way communication going on. So yeah, basically walkie-talkies. And then when I exit telnet, it says connection gone. And now if I look at this netstat again, right, and look for 1234, that connection has been shut down. It's in a time wait state. So it's basically in the process of going away. And then just to prove I'm not like pulling a fast one on you, let's go ahead and run this. And let's run terminus again. And let's go to our laptop connection. So it received a connection, and now I can type over here, and when I hit enter, it shows up over here. And that first one had some header stuff in it, but you know, I can say hello world and hit enter, and there you go. So that's all it takes really to get a network connection going, right? Those are the basic mechanics. I should close my connection too. Yeah, so I exited my program here, but of course, when you close an Android app, it doesn't exit, right? The whole life cycle of Android applications is different. Um, yeah, that one. All right, so how do I close this out? I don't know, actually. Um, it's a good question. Let's just close all. All right, so I'm going to close all. When I do that, then it says connection gone over here. All right, so there you go. There's networking. Um, so the only other piece to this now is everything else. But that's the mechanics of it, right? So once you can do that, once you can establish a connection and push information through, you can make another connection to push information in the other direction, and then it's just all management. So tomorrow we'll do Open Lab. Friday we'll introduce PA5, which will add a networking layer, and then we'll start building on top of this and see how we can do a well managed two-way networked communication, and that'll be the backbone for making dots networkable. So I'll go ahead and I'll post this code on Canvas, and we can talk about it tomorrow if you like, or we'll get into it on Friday. All right, cool. Thanks. Have a good one. I will talk to you next time.